Okay, here we go. Solutions to 2002 credit practice exam paper. First question, good old bod mass. So we need to do the 2.1 times 3 first of all. That gives us 6.3. And then 7.18, take away 6.30, 8 take away 0, 1 take away 3 we can't do, 11 take away 3 is 8, 0.88. Second question, turn the first fraction top heavy, so 8 times 2 add 1 is 9 over 8. Turn the second fraction upside down, 4 over 3. Wee bit of cancelling, 4 goes in there once, 4 goes in there twice, 3 goes in there once, 3 goes in there 3 times, 3 times 1 for the top, 2 times 1 for the bottom, which is 1.5. You would get away with leaving it as 3 over 2. Question 3, not much we can do with the left hand side. We can remove the brackets on the right. Then bring the 2x over as negative 2x and take the 5 over as negative 5. Tidying that up leaves us with minus 3x is bigger than minus 3. Swapping everything round about because of the negative signs gives us x is less than negative 3. Just note that the sign there has changed direction. For question 4, function f of negative 3, so put negative 3 in every place you see an x. Now it's good practice to write that line in, and then negative 3 squared is 9, 5 times negative 3 is negative 15, and 9 take away negative 15 is negative 6. Question 5, factorise. Well, this is a difference of squares, so that's p add 2q, p minus 2q. And then for the second part of the question, put those factors back on the top, so p add 2q, p minus 2q. Factorise the bottom as 3 bracket p plus 2q. Now we can cancel the p plus 2q on the top and the p plus 2q on the bottom, which leaves us with p minus 2q on the top and 3 on the bottom. Question 6, change the subject to h. So the first thing I'm going to do is get that over to the left hand side and get that over to the right hand side, so swap everything round about. So a half bracket h minus t equals L. Now, if I want h on its own, the 2 has to move, the minus t has to move, and that leaves you with the h. So, the 2 is on the bottom here, so it's dividing, so on this side it multiplies, the negative t goes over as positive t. So your answer is 2l plus t. For question 7, the cosine rule. Well, we know the cosine rule for cos A is b squared add c squared minus a squared over 2bc. So this is little b, this is little c, this is little a. So b squared, 4 squared, plus 5 squared, minus 6 squared, all over 2 times 4 times 5. 16, add 25, minus 36, over 40. 16 and 25 is 41. 41 take away 36 is 5. And 5 over 40 just simplifies to the answer that you're looking for. Question 8, 2 functions, f and g. Now you're asked to put them together. So you have to put f of x equal g of x. So let's just do that. X squared plus 2x minus 1 equals 5x add 3. Now we've got to solve this. The only way you solve anything which has got a power is to make the right hand side 0. So I'm going to bring the 5x over, and it's going to become minus 5x, so 2 minus 5 is minus 3x, and then bring the 3 over, minus 1 minus 3 minus 4 is equal to 0. Now we've got this side here as 0. Second thing we do is factorise. So x minus 4, x plus 1 for the factors. Given the answers, x is 4 and x is negative 1 for the brackets. Question 9. Root 27 is root 9 root 3. 2 root 3 we can't do anything with. Root 9 is 3, so that's 3 root 3's. Add 2 root 3's, which is 5 root 3's. Second part, let's deal with the brackets first of all. Now we have a rule which says when you've got a power raised to another power, you just multiply them together. So 3 times negative 2 is negative 6. And then for the last part of the question, you've got another rule that says that when you multiply, you just add the powers, and 8 add negative 6 is y squared. Question 10. Equal roots. Well, you know the condition for equal roots. For equal roots, b squared minus 4ac must be 0. This is really a higher question, not a national 5, but you get the idea. So identify your a. So what's before the x squared? There's a 1. What's before the b? There's a p. What's left for c is a 9. So plugging that into this formula, we end up with p squared minus 4 times 1 times 9 is 0. So p squared minus 36 is 0. So take the 36 over, square root, and your answer is positive and negative 6. Question 11. Simultaneous equations. I'm going to double the bottom one. So the top one I'm keeping the same. 4p plus 3g is 130. The bottom one is going to become 4p plus 8g is £2.40. Then I'm going to do a big subtraction. So I'm going to have that 5g's is equal to 0.90. So g must be 0.18. Once you know g is 0.18, then if I put it into the first question, I get 4p's plus 3 of those, 0.54, is equal to 130. So 4p is 130 minus 0.54, which is 0.76. And if I divide that by 4, that means p is 0.19. So to finish the question off, a peach is 19 pence and a grapefruit is 18 pence. Don't forget to write those as your solution. Now we reach the calculator section. Now I've obviously made a mistake with number 12 because there's no way in this world that a spider is going to weigh 19.06 kilograms. Anyway, assuming we've got a big massive giant spider who's 19.06 and the hummingbird is 18 times bigger than that, we just need to do that sum, which gives us 343.08. If we write that in standard form, 3.4308 times 10, and the numbers have moved 2 places, so at the power 2. As I say, I've made a mistake someplace, it can't be that. That would mean a spider weighs 343 kilograms. It's quite a lot. Number 13, the microwave was 150 after VAT was added at 15%. So we've got 115% of the price is equal to £150. So the price is, and it's a reverse percentage, 150 divided by, and 115% as a decimal is 1.15. And if we do that, we get an answer of £130.43. The other way to do it is, if you know that 115% is equivalent to £150, find 1% by doing 150 divided by 115, and then find 100% by times them by 100. And you'll get the exact same answer, £130.43. Question 14, quadratic formula. So A is worth 2, B is worth 3, and C is worth negative 7. Quadratic formula is negative b plus or minus square root of b squared minus 4ac, all divided by 2a. So sticking these numbers in gives us negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 7, all over 2 times 2, which becomes negative 3 plus or minus the square root of 9 add 56 over 4, which becomes negative 3 plus or minus root 65 over 4, or negative 3 plus root 65 over 4, and negative 3 minus root 65 over 4. Now typing those in the calculator separately gives these answers, and then rounding them off, the first answer is 1.1, second answer is negative 2.8. Oops, sorry, let's go back. Number 15, TV signal. Now we have to calculate the height of the satellite, so in other words we want this distance here. Now if we need that distance, the first thing we're going to do is we're going to find this distance. Once we've got that distance, we're going to use SOHCAHTOA to get the height. So how are we going to find that first distance over there? We're going to use the sine rule. So the triangle we had to start off with was 500 here, this is 35, this is 40. Now because we know the three angles in a triangle add up to 180, this one up here must be 105, and we're trying to calculate that side there. So x over sine 40 equals 500 over sine 105. Cross multiplying gives us x equals 500 times sine 40 divided by sine 105, which is 333. So we know that this distance here is 333. Now if we use a right angle triangle, this angle here is 35, this we've just worked out is 333, and we're trying to calculate this distance here. So it's a sine question, so sine 35 equals h over 333, so h is the 333 times sine 35, which comes out to be 191 metres. Okay, so it's a sine rule question to get a missing side, and then a SOHCAHTOA question. If you could do two sine rules, you should get the same answer. Question 16. From the diagram, let's make it a wee bit bigger so we can see what it is. Now we know that this distance here is 2.1. Now if that distance there is 2.1, then that also means that this distance here is 2.1. So if that's 2.1 up to there, and we know it's 3.4 up to the top, then that one there must be 1.3. We are trying to calculate the distance across here. So if we work out half the distance first of all, that little distance there, so using a right angle triangle with the information we know, 2.1, 1.3, let's call this distance y, and Pythagoras, y squared, 2.1 squared minus 1.3 squared, which is 4.41, take away 1.69, which is 0.72, and y is going to be the square root of that. Sorry, 4.41 take away 1.69 is 2.72, my mistake. 2.72, and then doing the square root of that would give us an answer of 1.65. X is double the distance all the way across it, so x is 2 times 1.65, which comes out to be 0.3 metres. Question 17. We have the blue line, which is the curve y equals sine x. We have a green straight line, 0.4. We want to find the points where they intersect, so we want to find these 2 points here. How do we do that? We put the two lines equal to each other. In other words, we solve sine x equals 0.4. So if we go back to our all sine, tan, cos diagrams, it's a sine question and they're positive, so I'm going to tick A and S. From the calculator, the second sine value for 0.4 comes out to be 24 degrees, and the answer in the sine box is 180 minus, so 180 minus that is 156 degrees. Now the question wanted the coordinates, so as well as the x coordinates we needed to find the y coordinates, but we don't need to find those because the question tells us there's 0.4 already. Y is 0.4. So point A is 24 degrees, 0.4 up. Point B is 156 degrees and 0.4 up. Now we'll have to go back to the last question because I forgot there was a second part. Second part says what other depth would give this width? Well, the other depth, which is the same as this one, is on the bottom here. Okay, and instead of adding the 1.3 on, we're going to take the 1.3 off. So 2.1, take away 1.3, the other depth is 0.8 metres. And then we reach number 18. Now this question is really two applications of similar triangles. The information we know is the height here is 1.5, the height here is 1, and that whole distance is 6. Now if I take these triangles and draw them out separately, so your big triangle is 1.5 and 6, small triangle is 1, and let's just call that x. We know from our work on similar triangles that 6 over x equals 1.5 over 1. Cross multiplying that gives us 1.5x equals 6 and x equals 4. So the x equals 4 is this part here. So if that part is 4, then that top part is 2. Then as the seesaw moves the other way around, the 2 goes down at the bottom and the 4 goes up in the air. Now it's still obviously 1 high where it swings. Now if I look at the two triangles I've got this time, this is 1, this is 2, this is 4, oh sorry, this is 6 still because it's still the same length, and we're trying to calculate x, this distance here. So again, from our similar triangles, 2 over 6 equals 1 over x, cross multiplying, 2x's are equal to 6, 1x is equal to 3 metres. So the height that the metal bar goes up is 3 metres. Okay, it's quite difficult, two sets of similar triangles, but hopefully you got enough marks in the rest of the paper.